Today we're looking at notes 8.3, polynomials and zeros. So you may have to pause this video to get all this information down first. Okay, the fundamental theorem of algebra, FTA, fundamental theorem of algebra, states that the degree of a polynomial tells you the number of solutions, including multiple and complex roots. So this is, as you can tell by the name, fundamental theorem of algebra. This is a really big deal. The degree, meaning the highest exponent of any polynomial, tells you how many solutions that you're going to have. And remember that solutions means zeros, roots, x-intercepts. That's what we're talking about when we say solutions. Okay, also, if A is a 0 or an x-intercept, means the same thing, remember. If A is a 0 of multiplicity n, then the behavior of the graph at the x-intercept A will be close to linear if n equals 1, close to quadratic if n equals 2, and close to cubic if n equals 3, and so on. So that means if you've got a root or a 0 in x-intercept that has a multiplicity of 1, then the graph is going to behave like a linear graph at that x-intercept. If the root has multiplicity 2, meaning it's a double, it will behave like a quadratic at that x-intercept. And if the root has multiplicity 3, meaning it's a triple, then the graph will look like a cubic at that x-intercept. Okay, and we're going to talk more and discuss and show some examples of that here in a minute. Okay, also, when a root, it follows from this that when a real root has even multiplicity, the graph touches the x-axis but does not cross it. Okay, we've seen that before and we will look at it again. When a real root has odd multiplicity greater than 1, the graph bends as it crosses the x-axis, like a cubic graph. So we will talk about that in a minute as well. So for example, this is exactly what we're going to be doing today. Given this polynomial, y equals, it's already pre-factored. The factor x plus 5, the factor x minus 1 squared, and the factor x minus 6 cubed. Okay? Given a pre-factored polynomial, it's very easy to see what the roots are. Remember that you set each factor equal to 0 and solve. If I set x plus 5 equal to 0 and solve for x, I'm going to get negative 5. And I only get negative 5 once because there's an implied 1 here. If I set x minus 1 squared equal to 0 and solve, I'm still going to get x equals 1, but we call that a double because you've got 2 of them. Okay, and similarly, if you've got x minus 6, you set it equal to 0 and you solve, you're going to get x equals 6, but that's a triple because you've got 3 of them. Or in other words, you could write x minus 6 3 times. Okay, so I want to discuss what these words up here mean and show it to you in the picture. So drawing a picture of this graph, okay, I have already taken and pre-filled in the x-intercepts. The x-intercept of negative 5, the x-intercept of positive 1, and the x-intercept of positive 6. So those 3 places are the only 3 places that this graph can cross through the x-axis. Think of these as like holes, like doors. The only places where this graph can get through the x-axis is here, here, and here. Okay? Now, you know that the right is going to be your rightmost end behavior. The leftmost x-intercept will exhibit your left end behavior. Well, we just talked about that not too long ago, so let's think about the end behavior of this graph. Okay, how many roots do I have? What's the degree of this graph? Well, I have 1 root here, 2 roots here, and 3 roots here. So 1 plus 2 is 3, and then 3 plus 3 is 6. So I know because I've got 6 roots, this is a 6th degree polynomial. Okay, this right here is a 6th degree polynomial. I've got 3, 4, 5, 6 roots. Okay, so 6th degree, even degree, means that the arrows face in the same direction, right? And more so what I can determine from this polynomial is out in front here, I have an implied positive 1. Okay, so my lead coefficient is going to be a positive value. Okay, so the positive lead coefficient means that my right end behavior is going to go up. So from this rightmost x-intercept, I'm going to draw an upward facing arrow. I know this arrow is going to face up. Okay, and from the leftmost arrow, because this is 6th degree and even degree means the arrows face in the same direction, I'm going to draw also an up arrow. Okay, and now all I need to determine is how does this graph go through these holes here? And that's based on what I was saying up here. So -5 is a single, right? That means it will behave like a linear graph. A linear graph just cuts through, so it's going to just cut through this hole here. So we call that a cut when we have a single. Okay, but at +1, at the x-intercept of +1, I have what's called a double. And remember that doubles will behave like quadratic, okay? And a quadratic looks like either a hilltop or like a U. So that's what shape I'm going to make here. And that also makes sense because it talks about here, even multiplicity, the graph touches the x-axis but does not cross it. So what I'm going to do is I'm going to touch the x-axis but not cross it. I'm going to make like a quadratic type shape there at that root. Okay, so that's what a double looks like, and we call that a bounce because you hit the x-intercept and bounce right off. Okay, and last but not least, my last root is x equals 6. That's a triple. So since it's a triple, it will behave like a cubic graph when I pass through that x-intercept at 6. So remember that a cubic graph almost looks like, I call it a snake. So when I go through this intercept there, it kind of, we call it slides in. So notice it's not the same as a cut. A cut goes straight through, but a slide kind of takes its time as it goes through the x-axis. All right, so basically what you need to know, a cut for a single, a bounce for a double root, and a slide for a triple root. Okay, let's look at some more examples here. So, find the zeros, state multiplicity only when it's greater than 1. If it's just 1, I don't need to know it's a single. Okay, and draw a rough sketch. So, this is a polynomial, okay? You can see it's pre-factored for you, and I've already set it equal to 0. Okay, and remember, if I set each of these factors equal to 0 and solve, so that's what I'm doing, I set each factor equal to 0. If I subtract 2, I'd get x equals -2. I'd get x equals 1 here, and I'd get x equals 3 here. Okay, all 3 of those are singles. They're not squared, cubed, nothing like that, so they're all singles. Okay, so when I come over here and draw my sketch, all right, I know I'm going to have a root at -2. I know I'm going to have a root at +1, and I know I'm going to have a root at +3. Okay, I've got 3 roots. That means I'm 3rd degree. Okay, odd degree means that I will have arrows facing opposite directions. The lead coefficient is positive, so I know the right arrow will face up. The left arrow will face down because odd degree means arrows face in opposite directions. If the right goes up, the left must go down. All 3 of these are singles, so I will just cut through, and cut through. Okay, oops, didn't mean for it to kind of squiggle there. So cuts on all those because they're all singles. Okay, moving along. Here I have a root at x equals -1 on this polynomial, but it is a double. Remember, I need to state multiplicity when it's greater than 1, and 2 is greater than 1. So x equals -1 is a double, and then x equals +5, this root here, is a single because it's not squared or tripled or anything like that. So then I'm going to come over here and I'm going to draw my x-intercepts at -1, 1, 2, 3, 4, 5. Okay, there's my x-intercepts, or my places in which my graph can cross through the x-axis. I have a double here and a single here, so 2 plus 1 means this is a 3rd degree polynomial. Okay, lead coefficient is positive, so that means the right arrow will go up, the left arrow will go down because odd degree, opposite directions. Okay, -1 is a double. A double is a bounce, so I'll hit that x-intercept, bounce right off. Okay, and then I can't go through the x-axis again until I get to that next door. Okay, think of that as your door, your passageway through. You can go through there, and it is a cut because x equals 5 is a single. Okay, moving along here, I've got x equals -2 as a root. It's a triple because it's got the 3 there, it's cubed. Okay, on this one, you might have to write it out. 3x minus 1 equals 0. If you add 1 to both sides, you get 3x equals 1. Okay, and then divide by 3. On this one, you'd get x equals 1/3 as your root. So I'm going to kind of skew this a bit. Make it look like this. Okay, -1, 2. And then +1. So I have a root at 1/3. There's my hole or my passageway. And then I have a root at -2. So there's my other passageway through the x-axis. Okay, I've got a triple here and a single here. So that's 4 roots. So this is a 4th degree polynomial, meaning my arrows will face in the same direction. My lead coefficient is positive, so both arrows will go up. Okay, the -2 is a triple, so I'll slide through as I go through. But my +1, or 1/3, is a single, so I'll just cut right through. Okay, this one's kind of curvy, this one's just straight on through. All right, so next example. Here I have a factor, a factor, a factor. Even though that factor is not in parentheses, it's still a factor. If you set -2x equal to 0 and solve, you divide both sides by -2, you still get x equals 0. That's a single that's not squared or anything like that. Okay, x equals -4 is a single. X equals +1 is also a single. Okay, so I've got 3 singles, which means I have a 3rd degree polynomial. So my arrows, odd degree, my arrows will face in opposite directions. Okay, so I've got, that's kind of crooked, so it'll probably bother me. If I can get it straight. All right, so I've got -1, 2, 3, 4. That's a passageway. I shouldn't call it a hole because we will discuss what a hole is later in the year. So that's a -4 is a passageway, +1, and 0. So those are the only 3 places my graph can go through the x-axis. Okay, 3rd degree, odd degree. Arrows will face in opposite directions, but my lead coefficient here is a negative. So that means my right arrow will go down. Since the arrows have to face in opposite directions, left arrow will go up. And those are all single roots, so I'll just cut through, and cut through. That one almost looks like a slide, but it should be a cut there. Okay, at +1. All right, so last example like this, x squared. X squared is a factor. If I set x squared equal to 0, okay, I'm still going to get x equals 0, and it's called a double because of the squared. Right? And then x equals 4 is a single, and x equals -1 is a single because of my factors. And so I will have a root at 0, a root at -1, and a root at 1, 2, 3, 4. So I've got a double, a single, so this is a 4th degree. Okay, even degree, arrows face in the same direction. Leading coefficient is positive, so both arrows face up. Okay, 0 is a double, but the rest are singles. So a cut, a bounce, and a cut. That's what your graph will look like. Okay, last example here, new kind of information. Last thing we're going to discuss, going the opposite direction. So write a polynomial with the given zeros. So if x equals -2 is a 0, x equals 2 is a 0, and x equals 3 is a 0, how do I write the polynomial? We'll go backwards and give the factors. If I've got a 0 at x equals -2, then I've got a factor at x plus 2. If I've got a 0 at x equals 2, I've got a factor at x minus 2. If I've got a 0 or a root at x equals 3, then that has a factor of x minus 3. So then to write the polynomial, technically, yes, this is already written as a polynomial if I say equals y, okay, or y equals, but let's put it in standard form. I know it doesn't say to, but let's do it. So foiling, I'd get x squared minus 2x plus 2x minus 4, okay, all that times x minus 3. So I multiplied those together equals y. All right, but I'm going to clean this up first. So those happen to cancel out. That's really nice. So x squared minus 4, x minus 3 equals y. So foiling this, I'd get x cubed minus 3x squared minus 4x plus 12. And you know what? Just because I like to put y equals in front, I will. And then it's already in standard form. Degree is from greatest to least. And so I'm going to circle that as my final answer.